This is a production of Cornell University.
Around the turn of the 20th century, Cornell professor Ralph Stockman Tarr and his students and collaborators organized several expeditions to glaciated areas in Greenland and Alaska. Hundreds of photographs taken during the expeditions captured both the stunning beauty of these areas as well as data that is proving valuable to the field of glaciology today. Drawing from this imagery as well as recent data gathered on-site and by satellite, Cornell Professor of Earth and Atmospheric Sciences Matt Pritchard highlights changes that have occurred in the glacial landscapes of Alaska and Greenland over the past 100 years. Professor Pritchard's lecture formally opened the exhibit, Historic Ice, Alaska and Greenland's Glaciers Through the Lens of the Cornell Expeditions, 1896 to 1911. Both exhibit and lecture were presented as part of special programming at Mann Library intended to showcase faculty work and further encourage cross-disciplinary thinking about climate change.
Well, thank you all for coming today. I will try to talk for about half an hour so that we can have some questions and then go up and see the spectacular pictures upstairs. They really look fantastic, and the staff here has done a great job of making large format prints of these things, as well as the digitization that has been going on over at some of the other libraries on campus. So I'll start with just a story about how we got started on this project. A couple of years ago, one of the emeritus faculty in our department, who's sitting right here, Art Bloom, was cleaning out his office and showed us some pictures that were taken on glass plates by this guy right over here, Ralph Stockman Tarr, who was a Cornell faculty member starting in the 19th century. And we got very excited about them, but in particular a postdoc at the time named Julie Elliott, who had gotten her PhD in Alaska studying Alaskan glaciers, and was very excited about the capabilities of being able to compare these historic pictures with the more modern ones. So a long story ensued of finding out what was in the Cornell archives here, a spectacular collection of images that probably hadn't been seen in almost 100 years in many cases, especially in the large format panoramic view like you'll see upstairs. And so as part of this, we were trying to figure out ways to digitize it, and so that's how we got Professor Aaron Sachs involved. And he's in the audience today, helping us to digitize this from the Department of History using a grant from the College of Arts and Sciences. We also have involved about 9 different undergraduate students here at Cornell and at Purdue, and one of them is also in the audience today, Sam Nadell. So we thank all of these guys and more for bringing us to this point today. So today I just want to give you a brief historical context, because we could talk a long time about the expeditions that occurred, led by Ralph Stockman Tarr and a variety of other Cornell faculty and students, to Alaska and to Greenland. We'll tell a little bit about just what have we learned by looking at the historical photos and comparing them with the modern ones. And I'll just focus on 3 particular glaciers that are highlighted up in the exhibit upstairs. Some of these glaciers are retreating, just like the majority of glaciers in Alaska, as you probably have heard from many other stories. Some are static. In fact, Cornell Glacier, that we'll show you pictures of in Greenland, is very far north and doesn't seem to have changed very much. And there are very few glaciers that get probably undue attention that are advancing, like Hubbard Glacier, but also have societal importance because they can shut off fjords that give access to other parts of the fjords in Alaska. And then I'll give you just a brief satellite global perspective to wrap up. So these, again, are like the introduction, that we're combining both local data of somebody on the ground taking a picture of glaciers 100 years ago and then again today, but how representative are those individual studies of the global perspective of ice. So as I mentioned, the primary person in our story today is Ralph Stockman Tarr, who was a Cornell faculty member for about 20 years, and he produced a variety of graduate and undergraduate students that he involved on these expeditions. One of them was this guy here, Lawrence Martin, a Cornell undergraduate and graduate student who was a faculty member at the University of Wisconsin, eventually worked at the Library of Congress, and the two of them wrote a seminal book, this book right here, on the glaciers and glaciation of Alaska. And so there's a copy of this up in the exhibit that you can thumb through. I guess I have to return my copy. This is a library copy right here. But it has fantastic maps in it, as well as a bunch of the pictures here that I'll show in the talk today. It was really the pioneering study of Alaskan glaciers for about 75 years until people could monitor them with aircraft and satellites. This guy here without any clothes on is Oscar von Engeln. who was a student and faculty member here at Cornell, he's reading his mail there. You can see this picture in a little better quality upstairs. Reading his mail, I guess after taking a bath in these icy waters. So this is an iceberg in front. You also see him developing some pictures there as well. And so he was the main photographer. He was a very gifted photographer, and you can in fact see his camera upstairs as part of the exhibit as well. So just to give you a sense of tying these people to the present day, there are two memorials to Ralph Stockman Tarr. So he was a very dynamic teacher, well appreciated on this campus, and died unfortunately at the age of 48. But there were two memorials to him on campus. One is this Tarr boulder, which is a glacial erratic that was deposited on the art squad next to McGraw Hall. You can go and sit on it, just like Professor von Engeln is here. And also there is a Tiffany stained glass window in Sage Chapel that I think if you squint hard enough, you can see there's a glacier in that valley there. So if you read, just to give you a sense of the tribute that the students had, this just says Ralph Stockman Tarr, scientist, writer, teacher. This boulder, a relic of the Ice Age, is symbolic of his research in glacial geology and of the enduring value of his work, is placed here as a memorial of their friend and advisor by his students. There's a picture of this. This picture is upstairs, again in better quality than you can see here projected. One of the great things about this is that this is the original picture. And you can see that they made one modification, the sculptor did. He did not want to include the pipe. So von Engeln, as I mentioned, was a very gifted photographer, and by some arguments, he took one of the most famous pictures of Cornell during its first 50 years. This picture right here, taken near the site of the old geology building, which is McGraw Hall, which is where the Department of History is right now, on the art squad. This is, in fact, a test picture that they took before going to Alaska. So taken in the spring. This was used widely in a variety of publications, including a couple of books that von Engeln wrote about Cornell history. You can see here it's on the cover of this one. And he also wrote a book about the local geology that is, in its second edition, graced by this picture that Art Bloom himself took. Also, if you're a local hiker, you might also be aware of von Engeln's name from the von Engeln Preserve. It's in the town of Dryden, and this is a place where von Engeln liked to take his field trips, and there's several important glacial features there, including this esker, which is a subglacial channel of sediments that was deposited when this area was glaciated tens of thousands of years ago. All right, so that's just give you an overview of the people that were involved in this. These are just some of the most important students, but several other Cornell students also went on these expeditions, both to Greenland and to Alaska. And the archives has a great collection of all of these objects. So in fact, this camera right here that they used on some of these trips is actually upstairs in the exhibit. So you can actually get a chance to see it very closely without having to go to the rare and manuscript collections, signing in, going through 3 levels of security, putting on your white gloves. You can actually see it here in the flesh. It's a spectacular opportunity, and we thank them for making that available. I mentioned that they took several different cameras with them. This is not the only camera. Some of the cameras they took with them actually were destroyed and fell into some of these treacherous rivers that you can actually see in the pictures. And some of the cameras also had this panoramic capability. So I came across these very wide aspect ratio pictures, and I was always wondering, how did they manage to take this panoramic picture with this sort of a camera? And I guess I've learned that back in that day, they had these spring-activated systems that would work, and you can see the spectacular results upstairs. There are also a variety of letters in these collections. It's a very rich archive that we're still just exploring. This is a letter by Theodore Roosevelt telling Tarr that he couldn't possibly serve on some committee that Tarr was asking him to serve on. All right, so as I mentioned, this project has involved many people over the years. Besides myself, we have sort of 9 undergraduate students. In particular, Julie Elliott is really focusing on trying to bring some scientific understanding from these pictures, and Aaron Sachs from the history department. All right, so just a brief overview of what the pictures have shown us and what we've learned from them. So just to give you an overview, what is a glacier? This is a sort of nice type example. A glacier is, as you might imagine, a large pile of ice and snow that has built up to the point that it starts to flow because it is so thick. So you have sort of zones of accumulation up at higher altitudes in the mountains. These pile up of snow. The snow turns into ice and flows down to lower elevations where it melts in this sort of zone of wastage or ablation at lower altitudes. So monitoring and understanding how fast these glaciers flow under different conditions is a very complicated problem and a very important one for understanding, in particular, as we'll talk about sea level rise and projections to the future. So this is just a couple of the different types of processes that are occurring on these glaciers that give us sort of these different feedbacks to changing climate. So one, as I mentioned, these glaciers grow by getting snow, and so if you change the amount of snow that's falling, that might change the rate at which they're moving. Or if you increase the amount of sunlight at the lower elevations or increase the temperature, that will also change their dynamics. But in addition to those sort of precipitation and temperature effects, there can also be interactions between meltwater on the surface of the glacier, inside the glacier, that gets down to the bottom of the glacier that might help to sort of lubricate the bottom of the glacier, that helps them speed up and slow down during different times of the year. Calving processes also can impact how fast the glacier is flowing. And then there are currents that can also impact the glacier and help to melt it from below. So all these different feedbacks are going on, and this is why glaciers are a complicated and fascinating thing to study, and why some glaciers have different types of responses to climate change. All right, so glaciers in Alaska, there are a lot of glaciers in Alaska, as you can probably tell, where, so this is showing just a typical map. Here's Anchorage over here, and Fairbanks up in the middle of the state. Juneau is over in this area. And all these green areas are showing glaciers. So Tar and students didn't go to all these places because, again, they were doing this sort of travel over 100 years ago. And so they primarily went to areas that they could reach by water or by the existing trains at the time. So in particular, they spent a lot of time in Yakutat Bay. You can see that this is sort of their different trips in 1905, 1906, 1909, and 1911 that they just went to again and again over the years, and so there's a great record of sort of annual change in that area. But they also ventured to several other areas. In particular, we'll be focusing on this area up here, Columbia Glacier, as well as Hubbard Glacier, which is down here, and then Cornell Glacier, which is in Greenland, which we'll come to in a second. So there's some great pictures of the group traveling to Alaska from Ithaca. So this picture actually is much better quality upstairs. Now that they've been able to take a picture from the archives. This is a picture of von Engeln and Tar taking the train from Ithaca all the way to Seattle, where they got on a steamer. There's a picture of them on the steamer traveling up to Alaska, which was, as you can imagine, a much longer trip than it would be today. One of the characters on there is sitting right in the middle. Benno Alexander wrote several poems about the people who went on these trips that you can read in a couple of publications. This was published in some Cornell literary publications by the students, just to give you a sense of what kind of camaraderie developed on this trip. So this guy lives in Alaska and worked with Tar and friends when he was there, and he was writing a poem basically telling Tar to come back. He says, "Come back once more, great work remains unwrought, and there is no one else to dare and to do." And this is what sort of daring and doing that they did. So this is just giving you a sense of when you're next to glaciers, especially in the summer in Alaska, there is a lot of meltwater coming off of them. So streams that are small become torrents, and this is just giving you some sense of the danger of crossing some of these much wild rivers, basically, on pretty uncomplicated trees and fording them and getting wet, very wet most of the trip. So you're dealing with a lot of water, you're dealing with a lot of insects, biting insects. So you read their diaries about the field work. It was not the most pleasant experience. And they had several near-death experiences by falling into this water. As I mentioned, they lost some cameras. They lost some of the plates as part of those episodes as well. This is giving you a sense of their camp life. So this is the expedition from the Department of Physical Geography, which is now part of the Earth and Atmospheric Sciences Department at Cornell. And this is giving you a sense of some of the other people camping there. Photography in the field. Just imagine using these film negatives and glass plates in the field, carrying your camera in a box like this with your tripod, developing the pictures in the field. So this is a darkroom tent that they used because I guess the emulsions at that time were much more effective if they were immediately developed than waiting some time after. And so several of their trips were funded by the National Geographic Society. So this is a famous picture that was in a National Geographic magazine and was auctioned off by the Society a couple of years ago for several $1,000s as part of their fundraising efforts. But this is also a great quality picture upstairs. All right, so a little bit about the glaciers. So as I mentioned, Columbia Glacier is really a famous glacier that these people took some photographs of, and you may have even have seen in some more recent documentaries and so forth, because it has had some spectacular changes since the time that Tarr and von Ingelen were there. One of the great things about this book that Tarr and Martin wrote was they tried to give people a sense of the size of the glaciers that they were studying. And this is always a difficult thing because these glaciers are just so large, it's hard for us to comprehend. So as far as I can tell, they were one of the pioneers of putting known objects next to glaciers. This is sort of a cliche now, but over Columbia Glacier, they put a map of the outline of Washington, D.C., and they put sort of the Bunker Hill Monument to give you a sense of the front of that glacier. So this is one of their nice panoramic views of Columbia Glacier. You can see extending from the mountain range all the way out here to these islands that were being overrun by the glacier at the time that they visited in the early part of the 20th century. So we have some pictures upstairs that show this in greater detail of the glaciers overrunning the trees. This is a clear sign of a glacier advance. That there were trees growing there. The glacier is now plowing those trees over, indicating that the glacier is growing in size. But since that time, primarily since the 1980s, the glacier has retreated very significantly, among the fastest retreats of any glacier in the world. And so it's received a lot of attention. So this is a movie that was made by a guy named James Balog as part of the Extreme Ice Survey. It was shown in a documentary called Chasing Ice that came out a few years ago, it gives a nice representation of how the glacier flows. So you can sort of see the nice flow of the glacier. You can see the seasonal cycle as the snow falls and then melts away, and you can see the chains of rock that are the moraines in the glacier. So this is just showing you over the course of, in this case, I think 4 or 5 years, how far that glacier has retreated. And again, here's a picture of using modern techniques. So instead of just going back like these guys did in the early part of the 20th century, taking one picture, coming back another year, we can now use these time-lapse cameras which show this variation so spectacularly. So this is just showing you the change of almost 20 kilometers in retreat of this particular glacier. So again, here was the view that we saw before of the glacier in the 1980s, which wasn't that different than where it was in 1906, sort of overrunning these islands, and then has retreated all the way back. And so you'll see some pictures for sort of the modern view of this glacier that's almost split into 2 different parts as it retreats backwards up the fjord. So again, this is an anomalous glacier. It's sort of one of the largest amounts of retreat. Not all the glaciers are doing this. And this is really one of the scientific interesting questions is, why does Columbia retreat so fast? Why do other glaciers retreat less fast? And some of them even advance. So there's this place here in Alaska called College Fjord. Let's see, is this actually? No. So here's Columbia Glacier. As you can see, it sort of had this long tongue sticking out. And you can see that it's been thinning at rates of several tens of meters per year. This is taken with comparing satellite images at 2 different times. And then over here in College Fjord, you can see that 2 other colleges, Harvard and Yale, are having totally different behaviors. Yale is retreating and Harvard is advancing in this story here. And a question I always get when I show this one is, well, where is Cornell Glacier? Well, first, just to show you that the satellite data agrees with these ground surveys, Tarr and company were not the only ones who were exploring Alaska in the early part of the 20th century. There were some other people from the USGS, and in fact, Tarr and Martin were funded by the USGS in part. And so this is showing the exact same view in College Fjord, showing Harvard Glacier that is actually advanced here. And there's the earlier view, and here's where it is today. So as I said, the question I always get, what about Cornell Glacier? Well, Cornell Glacier was named before most of these other ones during this 1896 expedition by Tarr and some other faculty and students from here at Cornell. So there's a great story that could be told about this. They collected some biological samples on their outing. I guess there's some fungi that they collected that's in the Cornell fungi collection here, as well as a large number of photographs. The primary purpose of the trip was being led by Lieutenant Robert Peary, who was a polar explorer, who was actually trying to go to the North Pole and eventually made it there, although there's some controversy about whether he was actually the first one there. But in this particular trip, he was trying to go collect the Cape York meteorite, which is a very large iron meteorite that's down at the American Museum of Natural History now. On this trip, they were scouting it out and realized they couldn't carry it. They had to go eventually build a railroad car that could transport it from land onto the boat. But in this case, Tarr was not part of the meteorite trip. He made a separate trip to another small fjord where he named Cornell Glacier. So this is two little arms of Cornell Glacier that you can see upstairs in this fjord. And you can sort of compare upstairs, maybe a little bit better quality. So here is another view of the north and south parts of Cornell Glacier, which are more or less in the same position as where they were when they were originally mapped back in 1896. So this is showing, you can sort of see the same features here. They named one of the mountains here after Cornell's president, Mount Sherman. And there's a nice medial moraine that comes off that mountain, and the glacier flow extends it downward here towards the coast that you can still see is still active today with the satellite view of the same area. And you can see basically the terminus of this glacier is more or less where it was back in 1896. All right, so that's a rapidly retreating glacier, a static glacier. Now let's talk briefly about an advancing glacier called Hubbard Glacier, which is in Yakutat Bay. So this glacier they also compared to all of the large glaciers in Europe. So this was a bit of a, here's a single glacier in Alaska that's as big as all the glaciers in Europe combined. And just to give a perspective to what you can imagine was a very European-dominated science of glaciology at the early part of the 20th century. So Hubbard Glacier is an advancing glacier. So here's a picture that is in a panorama upstairs, and you can see this nice little island right here. And here is a modern view that Julie took last year, where this is that island. It's being overridden by the glacier in this case. You can see a great view here of the glacier as it's going over the top. And so this is a couple more panoramas that are upstairs that sort of show the glacier moving forward. And the reason this is important is that the Hubbard Glacier almost cuts off this other fjord over here. So this fjord here is connected to the ocean, and when Hubbard advances, as it has a couple of times in the last 50 years, sort of advances, it chokes this off. The water, the sea life can no longer get to the ocean. People who want to go fishing up here and the communities that are up here are isolated in an area that becomes a lake, the water becomes fresh instead of salty. So there's a lot of negative consequences when Hubbard advances. And this is, as I said, it's happened a couple of times, and it's currently in this advanced stage and almost shut off that fjord. So the really interesting question that we're really motivated us to continue to try to look at all the glaciers in the pictures that Tarr and friends have taken and compare them to modern views is to understand this long-term behavior of the glaciers, because we do see this. A very few number of glaciers are advancing. Most of them are retreating. Why is there this different behavior? And the basic idea is what's called the tidewater glacier cycle, which is this cartoon that's shown over here, where there's an advancing phase that can last for hundreds of years at glaciers, where the glacier is pushing forward very slowly at a few 10 to 20 to 40 meters per year. It gets to a stable position, sort of maybe where Cornell Glacier is now. And if there's a little bit of an instability, if the glacier starts to retreat a little bit, then water can come in, get underneath the glacier, and make this rapid retreat. So that's what we think is happening at Columbia. It's in what's called the rapid retreat phase, where it can retreat up to 100 meters to a kilometer per year. But this is a very short-lived phase until it reaches a new equilibrium, and time goes by, and snow accumulates, and it can start its advancing phase again. So this is some idea of why Columbia is so much more rapidly retreating than other glaciers. But the clue that climate change is part of the story is that we would expect most glaciers to be in the advancing stage. That's the slow phase where it's slowly advancing over decades. And we would expect most glaciers to be in that phase, but in fact, as I said, we see about 99% of the glaciers in Alaska are in the retreat phase. So that's sort of an imbalance that's telling us that something has changed. All right, so we've sort of looked at the local scale. Let me just give you a brief summary of the global perspective that we can get from satellite observations. So we've talked primarily about Alaska and a little bit about Greenland. These are, but the big areas of ice on the planet, as you probably know, are Greenland, which has the equivalent amount of water of 7 meters of sea level rise, and Antarctica, which contains 57 meters worth of sea level rise. So that's how we sort of quantify how much ice is in these areas. If it all melted, how much sea level change would there be? In contrast, the glaciers in Alaska, the Himalayas, the Andes, and other areas corresponds to about 30 centimeters of water equivalent. So even though these glaciers are giant, the oceans are also very big. And so melting all that material and distributing it everywhere will add up to only about that 30 centimeters. But the important question, or one of the important questions, is how fast? How fast is the ice melting? How fast will it melt? And what are the different contributions to sea level rise? So currently, our satellite measurements tell us that sea level is rising about 2.5 millimeters per year. And the best estimates we have, there are some error bounds and some different estimates, but about half to 60% of the rise is just due to thermal expansion. That as the water heats up, it expands and causes sea level rise. But of the remainder, from melting of land ice, the majority, or about co-equal amounts, come from all these land glaciers and from Greenland and Antarctica combined. So the important thing is that these glaciers that are small in terms of their total water and ice content are the ones that are more rapidly changing right now. And that's probably because they're primarily at lower latitudes and lower elevations than the giant ice sheets in Greenland and Antarctica. And so for the next 100 years or so, these will probably be the most important contributions to sea level rise, although over the scale of its hundreds of years to thousands of years, of course, the big ice sheets will be more important. All right, so let me just briefly mention how we've expanded on the work that Tarr and von Engeld and others have done, and by having satellites to be able to make this global type of measurement. So there are three primary ways that we measure changes in glaciers around the world. One of them is that we measure changes in the height of the glacier. We use this tape measure, but in most cases we're firing a laser beam from a satellite down to the ground, and we measure how that distance has changed over time. Another way is that we can measure how fast the glaciers are moving by basically taking pictures at 2 different time intervals, comparing them, and watch how far the glacier has moved. And the final way is to measure the mass of the glaciers, and I'll show you how that's done with a pair of satellites called GRACE in just a second. So just to give you a visual sense, this is a glacier that we've been studying in Patagonia that's pretty rapidly changing. So I'll just go here between 2 images taken in 2001 and 2010, which can show you that this particular glacier is one of the most rapidly changing in this part of the world that we've seen by satellite. Again, a very remote area. We don't know if there are any ground photos that have been taken in this area, so this is a place where satellite images provide a unique perspective, where the glacier has retreated 4 kilometers in this 9-year time interval and thinned by about 450 meters. So that's about equivalent to the height of the Empire State Building. So this is a very rapidly changing glacier that we can detect, again, from space by measuring how the height using stereo images at these 2 different times has changed. So let's see if this one works. This is sort of showing the same glacier on a time span of about a week apart. That hopefully you can see that some of the crevasses in the glacier have moved. Can you guys see that? Can you see that? Maybe? Oh, sorry. All right, let's go back. All right, here we go. Oh, sorry, let me see if I can remember the right order here. Can you see in particular, just look at these crevasses right here. You see that, sort of? All right, so this is giving you a visual perspective of how we actually measure the glacier motion, is that we basically take sequential images, we can track features like these crevasses and figure out how fast they're moving at different time intervals. So this is showing how other workers have actually taken this technique of measuring velocities at different times to actually measure the velocities of the entire Antarctic ice sheet. So this is a nice visualization that's showing, using these combination of images, in this case radar images, you can actually see the rivers of ice. These are the rivers of ice that are flowing to the sea. In some areas, there's no motion that's occurring. It's sort of a drainage divide. And in other areas, this is all just showing evidence of the motion of the ice towards the shores. So let me show that one more time because it's so cool. So this is, again, only something you could do by satellite because this is a huge continental scale feature. We want to be able to figure out how the glaciers are moving for one, and then monitoring how those glacier motions are changing with time. And so this is just showing you the areas that are in purple are moving fast, and these are the slower moving areas that are moving into the sort of the tributaries to these large trunks of the streams that are moving into the ocean. All right, so that's motions of the ice and how we can map them. The final thing I wanted to show is the GRACE measurement. So again, GRACE is a pair of satellites called Tom and Jerry who chased each other and continue to chase each other around Earth orbit and are precisely measuring the distance between them. And the cool thing is that this allows you to measure any perturbations to the gravity field of the Earth as the ice melts or as a water table in an aquifer fills up with time. And the sobering fact is that both Greenland and Antarctica, measured by this satellite, are losing mass at a very fast rate. Greenland much more quickly than Antarctica. So this satellite was launched in 2002. This is giving you about the last 13 years worth of data. So you can see there's a strong seasonal cycle here as snow falls and then melts away in the summer, but the long-term trend is decrease, and in fact, it even appears to be accelerating. So just to give you a sense of the scale here, that we're talking about rates that are usually on the order of 280 gigatons per year. A gigaton is a hard thing to visualize, but about 360 gigatons is equal to about 1 millimeter of global sea level rise. So this is both of these two together are contributing about 1 millimeter currently of sea level rise per year. But the Greenland ice sheet is a big place, and at that rate, it would still take about 10,000 years to completely be removed. But of course, the key question that we still want to ask is the rate going to continue to accelerate? Could there be some other instabilities in the system that could lead to faster levels of sea level rise? And that's still an active area of research. As I mentioned, so this is showing Antarctica with the 3 different types of measurements, showing the areas where there's either changes in velocity, changes in height, or changes in gravity. And so you can see here that each technique can measure things with a slightly different level of resolution, but they all show sort of the same pattern. In particular, they're showing most mass losses occurring here in what's called West Antarctica. There's a lot of press recently about this area is possibly on an unstable course to completely collapse. And again, the question is that going to happen over hundreds of years or longer than that? But the interesting thing about Antarctica is that there's also an area of mass increase up here in eastern Antarctica, which is probably related to an increase in precipitation. So while temperatures are increasing, this area is very high and cold, and that also can lead to a little more precipitation, a little less of a polar desert type environment. All right, so that's our global perspective. And I'll just summarize here by talking about how satellite images are critical for monitoring the whole Earth and its changing ice. But these historic pictures are also very important for us to understand how things have changed at individual glaciers so that we can see in detail how has Columbia Glacier or Hubbard Glacier or Cornell Glacier changed in that time. And still areas of active research that we hope that these pictures can help us understand is why are individual glaciers changing at different rates, and how might we use that information to help us understand how sea level rise is going to change over the next coming decades. So in conclusion, I just again wanted to thank Art, who got our project started, all the library staff who have been involved in digitizing the pictures, all the library staff here at Mann Library who have helped make this spectacular exhibit, and then the funding we've gotten from the College of Arts and Sciences and some grants for the undergraduate research. So before I end, I wanted to at least give you a flavor of what TAR might have done back in the day. So if you guys want to hit the lights, I'll show you some of the lantern slides. So that's what this is, an old projector. I only have a couple of examples here, but there are a couple of lantern slides upstairs. So these are glass objects that, as you can imagine, if you're trying to give a lecture using all of these things and only having 2 of these at a time, I'm sure Art can give us lots of stories about how using PowerPoint might be a little easier in some respects and maybe not in others. But here's a picture of one of the gorges. I'm not sure which one. I think this might be Enfield Glen, you think? Treman State Park, yes. And so this is a picture from a field trip in the early part of the 20th century. And I'm showing this one in particular because there is a Cornell student in here named Ross Marvin who was a Cornell student and a Cornell faculty member in civil engineering and actually went with Perry on one of the expeditions, I believe in 1909, to reach the North Pole. Unfortunately, he perished during that trip, and so there's actually a memorial to him as well in Sage Chapel. All right, so let me just show you one more example here of what these lantern slides look like. Since I brought this thing all the way over from Snee Hall, I got to use it more than once. So just to give you a sense of a couple of other things about, so here's a picture of the quality of a picture from 1896. So this is a lantern slide. I don't think it was made in 1896, but it's using the picture that was taken by Tarr of somebody standing in this case, you can't tell, are they standing on rocks or are they standing on ice? In this case, they are standing on rocks in Labrador. That was sort of a glacially sculpted feature. The final thing I'll show is some diagrams that they often used in teaching using these lantern slides. And so this is a diagram. I should ask Art. I think this was probably, oh, that's backwards. Problem with words on here is you can actually tell when I put it in wrong. So this is a picture that von Engeln, I'm sure, and maybe Art, used in classes that shows sort of diagrams of what we think the paleogeography of the region looked like. In this case, this is showing Syracuse is right here. This is where the ice was as it retreated, showing some of the outwash plains and valley here at Tully, and then this nice waterfall, the fossil Niagara Falls that's over at Clark Reservation State Park, which is shown right there, which is presumably forming on the edge of the ice margin. All right, so I just had to show a couple of lantern slides because everyone loves them. But in the end, let me just thank you for your attention, and I'll take your questions, and then let's go up and look at the exhibit. Thanks.
This has been a production of Cornell University. On the web at cornell.edu.